And let me try to remember it.
Okay.
Oh, I can't remember it, but I remember the third law.
Okay, can you define the third law, Newton's third law of motion?
It says when object A exerts a force on object B simultaneously exerts a force with an equal magnitude somewhere there.
Okay. So can I safely say that Newton's third law is called action-reaction model?
I don't know.
It's all about action-reaction. If object A exerts a force on B, B will react in the same with the same magnitude of force.
Yes.
So the two pairs of forces are called action-reaction pairs. But it's fine. Okay. Newton's second law. Balenhle. Balenhle. Okay, no problem. So Newton's third law states that if a body attains a net non-zero force, it will accelerate, and the acceleration is given by the the force is given by the product of mass and acceleration. Are you aware of that one?
Are you talking to me or Mbalenhle?
Not to you.
Okay. When it says like something like, I'm remembering the little part of it, it says something like when a net or resultant force
Acts on a body, and the net force, when a net non-zero force.
Okay, yeah.
Because if it's a zero force, then we are talking about Newton's first law.
Okay.
Do you agree? I want you to agree.
Yes. I'm trying to
think about it. Okay.
Yes.
Can you see what is on the screen?
Yeah.
Okay, no problem. Let me summarize the Newton's law. Newton's first law, F net equals 0. Newton's second law, F net or F resultant equals mass times acceleration, whereby acceleration must never be 0. Okay. And number 3, action-reaction pair. Okay, that's fine. I was sent this question. Let us start from 2.2.1. Mbalente, what is a resultant vector? Okay, Tebucho, what is a resultant vector?
The sum of two or more vectors.
Okay, that's fine. It's a single vector that represents the sum of vectors. Okay, let me stop there. Okay, calculate the horizontal components of L, M, and N. I'm gonna give you 3 minutes.
Okay, let me start.
Okay.
I'm done, but I just can't do the horizontal. I can't calculate the horizontal component for N. I don't know how to do it.
Okay, so which one did you calculate? For L and M.
Yes.
Okay. What did you get for L?
I got 56,38 Newton.
Wait. 56,38. Okay. You got 56,28.
38.
38, okay. And then for M,
I got 2,090. 934.
2000.
934,49.
Okay, let's see. That's fine. Okay, let's do the corrections together. Okay, let's start by L. Remember, you are dealing with vectors, and vectors have direction. You must always state the direction.
Okay.
So for L, the direction is to the left. Do you agree?
Yes.
Okay. Okay. Oh, my pen. Okay, there we go. Okay, so this one is to the left, and for M, obviously it's gonna be to the right. You agree?
Yes.
Okay. Okay, obviously you are going to use trig ratios in order to calculate this. Okay, so your horizontal components, this is your horizontal component, and this is your vertical component, and this is your force. If this is your hypotenuse, this will be your adjacent. Okay, so sine of 45 equals adjacent over hypotenuse, which is my horizontal component divided by my force. So my horizontal component will be 80 sine of 45. 80 sine of 45, I think it's gonna give you 50, yeah, that 56.38. I trust in your answer, I'm not gonna calculate.
Wait.
Yes.
I found my mistake. Instead of using, I thought it was 150, and it's 80 apparently.
Oh, okay. So I was trusting your wrong answer, but it's fine. Times 80. No, but you got it right, most.
Yeah.
It's 56,
Mr.
56,57. Mbalente, you agree?
Oh, 57. Yes, I do agree.
Yes. Newtons. Okay, perfect. Now for L, again, we're gonna do the same thing. It's gonna be 60. This is for L, this is for M. So it's gonna be 60 sine of 20. 60 sine of 20.
It gives us 20,52.
60 sine of 20. 20,52, yes.
Yes.
So where do you get these thousands?
I told you that I used 150 instead of using.
Because even 150 won't give you 2,000.
Because I used cos. I don't know why I used cos.
Oh, and the other thing, I think you must fix your calculator. Maybe you are using grade instead of degree. You must check your calculator. Okay. Mbalanke, for n, for n, the horizontal component of n, what is it?
I didn't get that. I didn't understand this. So I was just.
Oh, okay. I would like to disappoint both of you guys. The horizontal component of n is 0.
Sir?
It is 0.
Why?
0.
Because it does not have a horizontal component.
Yes.
That force won't affect the horizontal forces, because that force is strictly vertical. It is not tilted.
Yeah.
So if it's not tilted, it does not have a horizontal component. It only have a vertical component.
Okay.
It does not have an angle. Does it have an angle?
No.
Therefore, it won't have the component. Or if you want to prove it, it's fine. Okay. If you want to prove it, it's fine. So do you agree that the angle that you are using is the angle that the force makes with the
90.
horizontal? Do you agree? No.
Could you repeat your
For
question?
instance, when you were calculating the horizontal force of M, you were calculating using the angle that M makes with the horizontal. Do you agree?
Yeah.
Yes.
Okay. The angle that N makes with the horizontal, do you agree that it is 90?
Yes. We
Okay,
once taught at school that
it is
whenever we
like,
are not,
sorry?
we were once told at school that whenever we're not given the angle, it is equal to the sum of an angle in a triangle.
No, we can't treat it in that way. Okay, can you
Oh,
please take your
the,
can you please take your calculator and say 40 times sine of 90, because this vector makes an angle of 90 degrees, and see what you're gonna get.
It gives us
40.
40 sine of 90.
Yes, it gives us
Yes, it
40.
is 40.
Oh, yes. I should have used the cos. You are right. This should have been the cos. Okay, can you say
Yes.
can you use the cos of 90? Let's see.
It gives us 0.
Yeah. So that is the component. So let me correct the other ones. Let me replace cos. Tebuch, I think your answer was right. It was 56.38. It's supposed to be the cos. 38, yes. Okay. And then 60 cos of 20.
Oh.
No, wait.
That
Yes. 80 cos of 45. 80 cos of 45. No, actually, it is 57.
yes,
As
because
yeah. And 60 cos of 20 is how much?
20,52.
60 cos of 20, it can be 20,52. I'm getting 56.
Oh, sorry, sir. I thought you were saying 60 sign.
No, this one. 56,38.
Because of yes, 56,8.
Okay, so we all agree that the horizontal component of n is 0, right? Are we on the same page?
Yes.
Okay.
Yes.
Determine the magnitude and the direction of the resultant force. Okay, 6 marks. I'm giving you 3 minutes to do it. 2.1.3.
Eh, eh.
Tebogo, are you done?
Yes.
Okay. Balente,
Okay.
are you done?
No. But we can, I'm struggling to do this, but we can do the corrections.
No problem. Akona, did you win?
Hi, sir. Sorry, I just joined. I didn't know what we were writing.
Okay, no problem. We were doing 2.1.3. We were finding the resultant
Oh,
force and the
all
direction.
right.
Yes. So we're gonna do corrections. The most important thing when you're finding the resultant is to know the components of all tilted vectors or tilted forces. Okay, so each and every vector which is tilted or which has an angle, it will have two components. It will have a vertical component and a horizontal component. We'll have a vertical and a horizontal component. Okay, that's fine. This one won't have a horizontal component because the horizontal component is 0. Okay, now according to Newton's second law, we have to add all the forces. The first force, but before we add the forces, we need to select the direction. Okay, I am going to assume that the upward direction is positive and the direction to the right is also positive. It means all the forces that are going the opposite direction will be negative. So I'm going to start by saying the horizontal component of M plus the horizontal component of L. Oh, sorry, the vertical component of M and the vertical component of L minus the vertical component of N. Will give us force net in the y direction. So I'm resolving forces in the y direction, or I'm resolving the vectors in the y direction. So we have already calculated this one. It was, haven't we? No, we haven't. It is going to be 80 sine of 45 plus L will be 60 sine of 20 minus 40 will give us F net in the y direction. So if you use your calculator, how much are you getting?
37,09.
37,09. Okay, I trust your answer. Okay, and then we're gonna resolve in the x direction, whereby we will have mx, which is positive because the force points in the positive direction, then minus L y component, because it points in the opposite direction, it's going to be a minus. Then our N does not have a horizontal force. It means those are the only two forces we're going to be dealing with in the horizontal direction. This will be F net X. So this will be, we have already calculated, the M is giving us 56,38 minus our L is 60 cos of 20 is how much? Let me see again. 56,38, okay? And 80 cos of 45. Oh, okay. Yeah, no problem. This was 57. Okay, yes, you're right. Okay, so it's 57. And then this is 56,38. Will give us F net in the X direction. Okay, so what is your answer, Tebuku? 56?
I did not minus mx minus lx.
Or did you add them?
Yes,
Why did you add them?
I don't know, but we are looking for the net horizontal force, right?
Yes.
So why are we minusing?
We are minusing it because this force is pointing in the opposite direction. Because we are dealing with vectors, you have to choose the positive direction. In this case, our positive direction is upwards and to the right. Any force that is going the opposite direction, it is going to be a negative force.
Okay.
Therefore, your horizontal M component is actually positive because it's going in the positive direction. Then the component of L, it is going in the opposite direction of our positive. Therefore, it is a minus.
Okay.
So if we minus these two, we are going to get, okay, 50.57 minus 56,38. I got 0,19 equals F net in the X direction. Okay, I just want to confirm something quickly. Sine of 45. I just want to make sure that we got the first one right. Okay, sine of 20 minus 40. Okay, yeah, you're right. You are right on the first one. Okay, so we have the F net in the Y direction, and we also have the F net in the X direction. So in order for us to find the resultant force, we know that we have the following situation. 0,19, and we have 37,09. So your resultant force will be in this direction. Do we all agree?
Yes.
Okay.
Yes.
Okay. So then the net force or the resultant will be equals to the square root of 37,09 squared plus 0,19 squared. Are you guys familiar with this equation?
Yes.
Yes.
Okay, no problem. So how much are we getting?
I'm getting 37,09.
or will you add the 2?
Yeah.
Okay, 37,09. Okay. Okay, and then the angle? The angle or the direction? Okay,
Yeah,
let's
we
solve
still
for the angle. Hmm. Do you agree with the tan of theta will be given by opposite, which is 37,09 divided by 0,19. It should be close to 90 degrees, but let's see. How much are you getting?
89.70.
89.70.
71, sorry. 71.
71, yeah. Yeah, it's close to 90. Yeah, we're fine. Okay, yes.
So how do you know it should be close to 90?
Because I just looked at that number, because that number is it's very close to 0. If the horizontal component is close to 0, it means that angle will be close to 90. Like the situation we had with this force, this one. The horizontal force is 0. So the angle should be about 90.
Oh, okay.
Yes. Okay, so that is our net force. Does anyone have any question? Especially here, I think most of you have a question on this one. Oh, are you answered?
yes.
Okay, because it's the same thing we did when we were solving forces in the y direction. These two are going upwards, so these two are positive forces, and this one is going in the opposite direction of positive, which is negative. Okay, that's fine. Okay, let's see if we have some more questions. Okay, this one. It should be very easy, but let's see. There you go. Copy. Insert. Yeah, this is what we have. This should be simple. Okay. We have a block of a mass 8 kgs, which is placed on a rough horizontal surface. The 8 kg block is connected to two other blocks by means of a light inextensible string, passing over a light frictionless pulley, as shown below. The magnitude of tension on T2 is 60. it is also given that T1 equals T2. 3.3.1 define Newton's second law. Newton's second law, F equals ma. This is Newton's second law. Okay. Draw the free body diagram. Let's do 3.1.2 and 3.1.2 and 3.1.3 together. 3 minutes. Okay. Tebogo, are you winning?
Yeah, I'm done.
You're done. Okay. Akona.
I'm still busy, sir.
Oh, okay. I'm gonna give you 1 minute.
Okay.
Akona, did you win?
Yes, sir.
Okay. How much did you get?
For the final answer,
Yeah.
okay.
We were doing 3.1.3, but we're now gonna do corrections for it. How much did you get, Akon?
4.0.
4 point
4.03.
4 point.
03.
Okay, no problem. 4.03. This is Akon. Tebogo.
I got 2,2.
2,2. Okay, let's see what we're gonna have. Okay, before I continue, when the system starts to accelerate, Tebogo, do you agree that the acceleration of the entire system will be the same acceleration of the 8 kg, and it will be the same acceleration that the 2 kg will have, and it will be the same acceleration that the 5 kg will have? Do you agree?
Yes, I do.
Okay, that means we can isolate any objects and calculate acceleration. But in this case, they want us to isolate 5 kg. That's fine. We will draw the free body diagram on the 5 kg block. Okay. Akona, what are the forces acting on the 5 kg block? The first one is?
We have the weights.
Okay.
And tension.
And tension.
T3.
T3. Okay. What else?
So for the 5 kg block, that's it.
Okay. Temuko, do you agree?
Yes, I do.
Okay, fine. Now, because we are dealing with vectors, we have to choose the direction. Usually, your teachers advise you guys to choose the positive direction as the direction of acceleration, which in this case is going to be downwards, because your system will accelerate downwards. Let us choose downwards as positive. Okay, so if we are choosing downwards as positive, force of gravity or your weight, if I'm resolving in the y direction, my weight will be positive. Fg minus T3, because it is pointing upwards, it is equals to force net in the y. Okay, so our Fg will be how much?
It'd be 59.
So it's 5 times 9,8. Okay. 5 times 9,8 minus T3 is 60. Okay. 60. Okay. Plus to force net in the y direction. So how much are we getting? 5 times 9,8. It's how much?
49.
49. So it's 49 minus 60, which is how much?
Negative 11.
Negative 11. Okay. Is equals to F net. Okay, fine.
Can I please ask a question?
Sorry?
Can I please ask something very quickly?
Okay.
Do you mind sharing the question paper so that we can also practice?
Oh, okay. Let me just share the bunch of all the question papers, because I got them from who sent me these questions? It was Kahleko. Kahleko, yes. Okay, so I'm gonna reply. Okay, if you go to the group, you'll see. Okay. Okay, so our F net is minus 11. And we know from Newton's second law that F equals MA. So minus 11 equals MA, mass times acceleration. And we know the mass, 5 times acceleration. So if we divide by 5, both sides, our acceleration will be minus 11 divided by 5, which is minus 2
Negative
2
Yeah.
meters per second squared. I think one of you guys got it right. Yeah. Yeah. Temuko got it right. Okay. is the system moving upwards or downwards?
The system is moving downwards.
Okay. Do you agree that the force of gravity on the 5 kg is 49, right?
Yes.
And the tension is 60.
Yes.
$60 is greater than 49. The resultant force is upwards.
Okay.
I don't know if you agree.
Yeah, I see it.
Okay. I'm just saying, so that is why our answer was negative. It is negative because our acceleration is against the positive direction that we have chosen, which was downwards.
Is it possible for acceleration to be negative?
Yes.
Okay.
Yes, it is positive. It is possible because it depends on which direction you choose.
Okay.
Okay. Now they are saying draw a free body diagram showing all forces acting on the 8 kg block. Okay, 2 minutes. Katlego, we are doing your question papers. We are now doing 3.1.4. There's something that I'm noticing on this paper. There's a very big mistake that the examiners made. They said the tension T2 is 60, but on the diagram, they are saying T3 equals 60.
Yes, sir. That's what also confusing.
Yes. So that is why the answer is not practically right. There's no way acceleration can be going upwards. What is it that is pulling the system upwards? So whoever made this question, okay, they made a mistake. Let's agree. So T2 is equals to 60 instead of T3. But if I was your examiner, I was gonna give whoever used T3 as 60 or T2 as 60, I was gonna give both of you all the marks. But let us correct and see what we're gonna get. If we are trying to be realistic, a T3 is not equals to 60. So if that was the case, it means we have to include 2 kg in this case. If we want to calculate the proper acceleration, we have to include the 2 kg. So our system was going to be 7 kgs with T2 equals to 60. And then our weight was gonna be 7 times 9.8 is how much? $68.
68.60.
Now this makes sense. This makes sense because the system will be going downwards. So your force net, if we choose downwards as positive, 68.6 minus 60 will give us force net, which is equals to MA. And our M, in this case, it is 7. So we have 7 times acceleration. 68 minus 6, 68.6 minus 60 is how much? It's going to be 8.6.
Yes.
So if we divide by 7, our acceleration will be 8 points. It will be 1.23. 1.3. Okay. 1.3 meters per second. 1.3.
1.23. 1.23.
So
Okay.
1.3. Oh, 1.23, yeah.
Yes. So realistically, this will be the acceleration. Okay. So let us draw the free body diagram showing all forces acting on the 8 kg block. George, we are doing 3.1.4. Draw the free body diagram showing all forces acting on the 8 kg block.
Noted, me.
Orange. Busha, are you done? Katlebo, are you done?
Yes, I'm done.
Okay, can we do 3.1.5 as well? Are you done?
Yes, I am.
Okay. George?
Currently not.
Corner?
I'm still busy, sir.
Okay. Okay. I'm gonna give you another 2 minutes. It's fine. Puse, we are doing 3.1.4 and 3.1.5 all together. Okay. Use, are you done? Bushe, are you done?
Yes, sir, I'm done.
George?
Yes, I'm done.
Okay. George, how much did you get?
For 3.1.3, I got 1,23 meters per second.
Okay, that one we've got. On 3.1.5?
Oh. I didn't do. I thought you said we must do 3.1.4. So the page didn't go on. So like it's blank here.
Okay. Okay, no problem. Bushe, how much did you get for 3.1.5? Akona? How much did you get?
I got 15.68.
Okay, 15.68. The frictional force.
Yes.
Akona, how much did you get? Katlego? Katlego?
Sir,
Yes.
I can't see the screen.
Oh, you can't see the screen. Okay, let me reshare. It's fine. Can you see now?
Yeah.
Okay. How much did you get for 3.1.5?
I got 9.68 newtons.
9.68. Okay. Katlego? Okay, no, it's fine. Puse? Okay. Yeah, now we can do it together. So the free body diagram for the 8 kg will be as follows. Let me find a space. Okay. We have the frictional force. We have the normal force. We have the force of gravity. We also have the tension, T1. Okay, Tebuho, did you get something of this sort? Get something along this line?
Yes, yes.
Okay. And the angle was 30 degrees. Okay. Okay, fine. So I'm gonna take that and try to solve for the frictional force. Okay, so we have, if I have a free body diagram, I have friction, I have normal force, I have weight, I also have tension, T1, which is acting 30 degrees. Okay, so if we are resolving forces in the y direction, first of all, we have to choose the positive, we have to choose the directions. Okay, I'm gonna choose right as positive and upwards as positive. So if I'm resolving forces in the y direction, I am going to have normal force minus weight plus T1 sine of 30 is equals to F net in the y direction, which is equals to 0. Does anyone have any question on this equation? Okay, that's fine. Yes.
Are we gonna be penalized if we include the angle on our free body diagrams?
On your free body diagram, if you include the angle, no, you won't.
Are we gonna be
If you don't,
okay?
no, you won't. It's either you choose to include the angle or you can write it in this way. You will have your normal force, then plus your tension component in the y direction, and also the tension component in the x direction. You can write it in this form. You will get your full marks. It's the same thing.
Okay.
Okay. So your normal force would be given by, if I take W to the other side, we'll have W and the minus T1 sine of 30, which is mass times acceleration, 8 times 9,8. Mass times gravitational acceleration minus, we were told that T1 and T2 are equal, and T2 is equal to 60. So this is 60 sine of 30 degrees. So what do we get? Anyone with a good calculator? Because mine was giving me problems. Okay.
48,4.
48,4 newtons. Okay, so the frictional force okay, yeah, so that is the normal force. The frictional force is given by the coefficient of friction times the normal force, which is, are we given the coefficient of friction? No, we are not. Therefore, we cannot calculate friction in this way. Okay, now let us resolve in the x direction. In the x direction, we know that frictional force we know that tension cos of 30, which is in the positive direction, minus friction, it will give us force net in the x direction, which is equals to mass times acceleration. Okay, we have already calculated our acceleration, and it tends to be, our mass is 8 times our acceleration tends to be 1,8 2, 3. So T1, we are trying to calculate frictional force. So T1 cos of 30 minus 8 times 1,23 is equals to, if I take friction to the other side, it will have a positive sign. And your T1 was given by 60. 60 cos of 30 minus 8 times 1,23 will give us the frictional force. So what are we getting? Sixty cos of 30
42,2.
we are getting 42,12 newtons. Okay, let me go back to my force diagram to check. Yeah, so I'm getting 42,14. Does anyone have any question on that one?
Yes, I do.
Okay.
We have-
Which part?
Why didn't you use the coefficient of kinetic frictional force? Because it's given.
Is it given?
Yes, it's 0,2.
Oh, yes. Okay. If the coefficient is 0,2, we have 0,2 times the normal force. Your normal force is equals to 48,4. Okay, so how much are we getting?
9,68.
9,68 newtons. And okay, so that will be the frictional force. So in case if we were not given the coefficient of frictional the coefficient of frictional force, this is what we're gonna do.
Is it the same answer though?
It is not the same. It is not the same answer.
Why?
Something I've realized about the person who was setting this paper is that, let me just say, they didn't know what they were doing.
Okay, fair enough.
They didn't know what they were doing. I think there's fewer examples I can show you. For instance, they said T2 is given by 60 newtons, but on the diagram they wrote T3 equals 60. That's one example.
Okay.
Yeah, so if you were not given the coefficient, then you are going to have to calculate it using the way that we did. Because if the frictional force that you have calculated using by resolving forces in the x direction is different from the one that we have calculated using the coefficient of friction of 0.2, if they are not equal, it means there's something wrong. They are supposed to be equal. So whoever was setting this paper did not check.
Okay.
Yeah. So I think we are running out of time because I have to go and watch rugby. So I guess I will see you guys tomorrow after church, where we will do stoichiometry. And if there's any question on electricity, we may try to do them as well. But the main focus will be stoichiometry. Okay.
Okay.
So I will see you guys tomorrow, 2 o'clock after church.
Okay.
All right.